Welcome to Two Projects. In this video, we are going to explain the project Network Traffic Prediction Model considering road traffic parameters using artificial intelligence methods. Before diving into the execution, let me give you an overview of the project. So, the project aims to improve traffic management in urban areas by developing a network traffic prediction model using artificial intelligence techniques. So, network traffic refers to the flow of data across a network, including internet browsing, file transfers, email exchanges, and multimedia streaming. So, we will be using road traffic parameters to predict the network traffic flow. The process begins with exploration of the dataset, followed by pre processing and data visualization techniques to understand relationships between variables and identify patterns. And machine learning algorithms and ensemble methods are used to build the model, including random forest, decision tree, support vector machine, voting classifier, and a stacking classifier. So we will be training these models and will select the best performing model among them for network traffic prediction. And the Flask framework is used to create a web application interface for users to interact with the model, and integration with SQLite enables user authentication. The model generates predictions based on input data and learned patterns, allowing users to visualize predicted traffic patterns and make informed decisions. So, this project benefits urban planners, policymakers, transportation authorities, and commercial entities by providing accurate predictions for efficient infrastructure planning and resource allocation. This is what happens in this project. Now we look at the software and hardware requirements to execute this project. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, back-end framework needed is Jupyter Notebook, database required is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we'll look at the algorithms built. So in the base paper, author has proposed to compare random forest decision tree and support vector machine. For improved performance, we are proposing these ensemble models, voting classifier and the stacking classifier. Voting classifier has been built combining random forest decision tree and support vector classifier, and stacking classifier has been built combining extra tree, linear support vector classifier with logistic regression as the meta classifier. So we have trained all these models. We have compared them using different performance metrics like accuracy, precision, recall, and F1 score. And we have observed that stacking classifier has outperformed other models. So we have deployed it into the Flask framework. We will be executing the project using Flask web application. Before execution, first we need to open the code folder which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. This is static folder which consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes coded in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And this is dataset CSV file in which I have required dataset on which we'll be training the machine learning models. So the dataset comprises geographical coordinates, traffic direction, road identifiers, average vehicle speed, flow rate, traffic concentration, and status. So it enables analysis of traffic patterns and conditions, aiding in effective traffic management and infrastructure planning in urban areas. So we will be using this data set to train the machine learning models to predict network traffic. So we have pre-processed this data and we have stored the pre-processed data set in this pre-processed CSV file. And this is a model file which contains algorithm information. This file will be loaded into the project code during runtime to utilize the trained models. This is Notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. This is test cases, text data, in which I have test cases on which will make the predictions. This is signup.db file. This file is the database file used to store user information. It stores information like user signup details. So this is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. This is the path. I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command executes the Python script and performs a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. Here we can see a logon link, click on it. So if we are already a member, we can directly log in by giving the username and password. And if we are new to the system, we have to sign up first. Click on the sign up link here. Fill in these details and click on sign up button to register. So as I'm already a member, I'm clicking on the sign in link. I'm giving my credentials here and click on sign in button. So it has redirected us to the predictions page. So now we have to fill in these parameters and click on submit button to get the predictions. First, we'll understand these parameters. The first one is date time. So it records the date and time of traffic observation. Next comes latitude and the next parameter is longitude. So latitude and longitude pinpoint the location of data collection. The next parameter is direction. It indicates traffic flow direction and we have two options, inbound and outbound. Inbound is the traffic moving towards a central point or destination. Outbound is traffic moving away from a central point or destination. The next parameter is road. It identifies the specific road or segment. So these are the options we have. Next comes the vehicle speed. It is the average speed of vehicles. Next parameter is vehicle flow sensor rate. It is the rate of vehicles passing through a sensor. And the last parameter is traffic concentration. It is the density of vehicles in the area. So these are the parameters. Now we have to fill in these parameters to get the predictions. So first we have to enter the date and time. Here we can see a calendar symbol. Click on it. Select the date and time from here. I have selected the date and time. Latitude would be 49.493. Longitude is 5.947. Direction would be outbound. Road is B40. Vehicle speed would be 58. Vehicle flow sensor rate would be 114 and traffic concentration is 0. Now click on submit button. So here we can see the result, that is based on the speed and vehicle count, the network traffic is congested. So according to the given set of parameters, the parameters related to road traffic, the application has predicted the network traffic as congested. So it indicates heavy traffic. Click on home link will try giving another set of parameters. Select the date and time. I have selected the date and time. Give the latitude. I am giving it as 49.497. Longitude would be 5.953. Direction is outbound. Road would be A13. Vehicle speed is 79. Vehicle flow sensor rate would be 1139. And traffic concentration would be 1. Now click on submit button. So here we can see the result, that is based on the speed and vehicle count. The network traffic is congested. So according to the given set of parameters, the application has predicted the network traffic as congested. Click on home link, give the date and time. Latitude would be 59.32. Longitude is 5.947. Give the direction. I'm giving it as inbound. Road is A7. Vehicle speed would be 58. Vehicle flow sensor rate is 1574 and traffic concentration would be 6. Now click on submit button. So here we can see the outcome, that is based on the speed and vehicle count. The network traffic is impossible. So impossible indicates that it is not feasible to make a prediction based on the available data, that is given set of parameters. We'll try again. Click on home link. Give the date and time. I have entered the date and time. Latitude would be 49.491. Longitude is 5.953. Direction is outbound. Road is B40. Vehicle speed is 81. Vehicle flow sensor rate is 132 and traffic concentration is 0. Now click on submit button. So here we can see the outcome, that is based on the speed and vehicle count. The network traffic is free flow. So free flow indicates smooth traffic flow with no congestion. According to the given set of parameters related to road traffic, the application has predicted the network traffic as free flow. Click on home link. We'll try with some more test cases. So this time, select the date and time first. I have selected the date and time. Longitude would be 49.491. Longitude would be 5.953. Direction is inbound. Road is A13, vehicle speed would be 29, vehicle flow sensor rate is 414, and traffic concentration is 18. Now click on submit button. So here we can see the outcome that is based on the speed and vehicle count. The network traffic is unknown. Unknown indicates uncertainty in predicting traffic conditions due to insufficient data or unexpected circumstances. So according to the given set of parameters, the application has predicted the network traffic as unknown. Click on home link, give the date and time, enter the latitude. I'm giving it as 49.497. Longitude would be 5.942. Direction is inbound. Road would be A7. Vehicle speed is 9. Vehicle flow sensor rate is 1171. Traffic concentration would be 26. Now click on submit button. Here we can see the result that is based on the speed and vehicle count. The network traffic is impossible. Click on home link, select the date and time. So latitude would be 49.497. Longitude would be 5.942. Direction is inbound. Road is V40. Vehicle speed would be 82. Vehicle flow sensor rate is 96. And traffic concentration is 0. Now click on submit button. Here we can see the result that is based on the speed and vehicle count. The network traffic is free flow. That means the traffic is smooth, the flow is smooth with no congestion. So in this way, we have to enter the parameters here, click on the submit button and get the predictions of the network traffic. Now click on the about link here to look at the visualizations. So this is the sample outcome graph, which displays the distribution of labels. In this graph on x-axis, I have the class labels, and on y-axis, I have their counts. So we can see there are more number of cases of congested in the data. This is accuracy scores comparison graph, a horizontal bar graph comparing accuracy scores. So in this graph on x-axis, I have accuracy scores, and on y-axis, I have algorithm names. These are all the algorithms built. So accuracy is a measure of how well a model correctly predicts outcomes. It represents the proportion of correctly classified instances among all instances evaluated. Similarly, this is precision scores comparison graph. Precision is a measure of the correctness of positive predictions made by a classifier. This is recall scores comparison graph. Recall is a measure of the classifier's ability to correctly identify all relevant instances from a dataset. And this is F1 scores comparison graph. F1 score combines precision and recall into a single metric. It provides a balance between precision and recall, taking into account both false positives and false negatives. So we can see all the algorithms are doing well in all the performance metrics. We have deployed stacking classifier into the Flask framework. So these are the graphs. Now click on logout. So the project's network traffic prediction model incorporating road parameters and AI methods enables accurate traffic predictions for proactive management. Through advanced ensemble techniques, it contributes to enhanced urban traffic control and infrastructure planning, ultimately improving commuter experience, efficiency, and resource allocation in urban environments.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.